Welcome to the VMware Cloud PKS demo. In this video, we're going to show how you can bring up an enterprise-grade, production-quality Kubernetes cluster and start deploying complex multi-tier application in minutes. To start consuming Cloud PKS, you first log into the VMware Cloud PKS portal. VMware Cloud PKS portal leverages OpenID Connect for authentication. Once logged in, you will have the option to create a Cloud PKS Smart Cluster. Cloud PKS Smart Cluster comes in multiple form factors. We will review those form factors in detail. You can also have the option to access existing cluster that has already been deployed using your single sign-on credential. Cloud PKS offers the ability to organize resources through the use of folders, projects, smart clusters, and namespaces. And also you have the ability to manage access policy by assigning users and groups to existing folders and projects. So to deploy a cluster is super easy. Simply click on the new cluster icon. You have two types of cluster to choose from. You have we support the deployment cluster where it's best suited for a testing type of activity where redundancy is not a requirement and you just want to quickly validate to see if your app is behaving the way it is. And they also have the option to deploy a full production cluster, and this full production cluster has high availability, right? Both in terms of the cluster itself as well as the redundancy across multiple zones and different availability and through use of multiple master nodes and etc the database. For both the development and the production cluster, you have the ability to select the version of the Kubernetes you want to deploy, and you also have the ability to look at the networking resources that will be recreated to support the underlying cluster infrastructure. So in the case of development cluster, the addresses are fairly fixed. You don't have the ability to update those. But for the production cluster, you can actually customize the addresses based on your organizational policies. So you can change the subnets, but you need to make sure that you do not overlap the IP subnets with existing resources you have in your VPC. Now we have the ability to deploy a cluster across multiple geographic regions. You have US West, you have Europe, or you have US East. This is Virginia, and I'm going to select US East for my cluster here, and then also I'm going to enable privilege mode. And basically, privilege mode allows you to deploy pods with escalated permission. Example of that would be Fluentd. And by using the privilege cluster, you should be able to deploy those. Just be aware, there are some, when you are making the cluster privilege, there are some risks associated with it from a security perspective. And then I'm going to assign a name to my cluster, and then I can go ahead and create the cluster. A smart cluster with full HA takes roughly 5 to 10 minutes to create. By default, we only provision Kubernetes worker node based on application demand. So if there are no application, we will not create any worker node. A newly created cluster will always have 0 GB of memory and 0 CPU provisioned. We create 4 default namespaces. The view-ke-system namespace is where the smart cluster control plane resides. You can also create new namespaces directly from the UI. Here I'm creating a new namespace called demo and assign a description, and the new namespace is now created. I could also launch the Kubernetes UI to the new cluster directly from the dashboard as well. We leverage your single sign-on credentials to access the Kubernetes UI, and once you are in the Kubernetes UI, you could start to manage the new namespaces you have created. You can view your workload specific information such as the deployments, cron jobs, daemon sets, and you will also have the ability to actually deploy application stack directly from the UI but for the purpose of this demo, we're going to use the kubectl later to show the application deployment. Now we're going to demo how you can manage the newly created cluster using the Cloud PKS API and CLI. To enable Cloud PKS CLI access, you first log into your org using your org ID and the refresh token. Then you specify the location of your smart cluster by specify the folder and the project. And once you specify the folder and the project, then you can list the available clusters within that project. After that, you will set up the authentication information of our newly created cluster by using the cluster auth setup command. The cluster setup auth command effectively updates your kubectl configuration file with your OIDC token and sets the cluster context to the cluster you specified. Once that is done, once the kubectl config is generated using the auth command, now you can leverage the native Kubernetes command to manage your cluster. Before I demo the Cloud PKS CLI, let me first show you where to obtain the organization ID and refresh token. You can obtain the organization ID by click the org name and the organization ID field from the UI. To obtain the refresh token, click on My Accounts, API token. Refresh token is the first line on the newly generated page. Successful. And we'll set the folder context. Set the project context. And now I can look into my cluster. Once I have this information ready, I will then set up my cluster. And once this is set up, I now have the ability to look into the namespace and pod, which is nothing. This default Kubernetes service. So now we're going to look at how to deploy application on the cluster that we have just deployed. So we're going to look into the node status. So we have a concept of a smart cluster, meaning that we are not going to create any worker nodes until there's an application that requires it. Now let's create an application. So I have a demo chat program. So I have this program here that basically is a very simple two-tier application with a front end and a MongoDB. And then to support this application, basically you have a front end deployment. Is two deployments. You have a Kubernetes deployment for front end, and then you have a database, Mongo database with one replica set, and then you have two types of services, the internal DB, and then you have the external load balancer service that's accessible from the outside. And I'm going to show how this is going to be consumed. So let's look at the demo. So this is a deployment with 3 replicas and with port 5000 and with the load balancer type. And this is the type load balancer here. So I'm going to create this application. The first action Cloud PKS will perform is to create sufficient worker nodes required for the application. And once the worker node is created, Kubernetes scheduler will schedule the pod and service creation on the new worker node. Once pods and services are active, Kubernetes will then register the newly created pods to the services based on label selector. A label selector is something you defined in the YAML of the Kubernetes configuration, and that basically determines what resources map to what services. Once we confirm the expected pods and the services are running active, we can then use the kubectl describe service command to obtain the external IP address, or in this case, the load balancer that's required for us to reach and validate the application. Simply copy the fully qualified domain name of the address and go to your browser and open a new window and paste the address into the URL window, and now our application is running. This concludes our demo. Thank you so much for watching the video, and I hope you find this information to be helpful, and I encourage you to try out Cloud PKS today. Thank you.